VLAN routing in Fortigate Firewall. This is a step-by-step, and this is the topology that I'm going to use. Welcome again. I'm going to configure inter-VLAN routing in Fortigate Firewall. In GNS3, this is the topology that I'm going to use. As you can see, this is the cloud. I'm going to access this firewall using this, and this one will help me to get the IP address that I can access this firewall in the web. This is the switch. It's a layer 2 switch. You can see this is department 1, that is a department called sales. Then this is the finance. Under VLAN 20, this is VLAN 10. I'm going to simulate the same to ensure that communication or traffic from VLAN 10 is able to be forwarded to VLAN 20 and vice versa. So remember, just as inter-VLAN routing in Cisco router, whereby we use 802.1q, Fortigate Firewall has also that capability to facilitate inter-VLAN routing. Summary, just the communication among VLANs. Remember that communication within the same VLAN happens effectively, but communication between two VLANs or among VLANs cannot go through not unless there is a layer 3 device, which is a router or a layer 3 switch. So in this case, I'm going to focus on using Fortigate to help me ensure that this communication between these two VLANs happen. So the first thing, I'm going to create VLANs, assign switch ports on the VLANs in this switch. And also the next thing, I'm going to enable routing on this Fortigate. So let me start. My devices are all powered. So this is a switch. Let me make it bigger for you to see. I can give it 20. So hostname, main, switch 2, or I can give it netlabs, hub, switch 1, still it can work. So VLAN 10, name sales, VLAN 20, name finance. So the next thing is to assign switch ports to the VLANs. To assign switch ports, you go to global configuration mode. You specify the range of switch ports. Like in my case, VLAN 1 is happening on Ethernet 0/2 and Ethernet 0/0. So what I'm going to do, you specify the range because I'm going to bundle more than one interface. So Ethernet 0, 1, 2, 2. Switch port mode access, switch port access, VLAN 10, description, sales department, and next, interface, range, Ethernet 1. Let me check. You can see Ethernet 1 up to 3. So Ethernet 1/1 up to 3. Switch port mode access switch. So like the mode here, it should be in access to ensure that traffic pass through. When it is trunk, that has a different function. So switch port access VLAN 20. Description, finance, department. So after there is to configure the trunk port. The trunk port is a type of a port that acts as a conduit or a tunnel to allow communication from one VLAN to the other. So this port here, Ethernet 0/0, this is going to be a trunk port. It will be the one allowing traffic from these two VLANs going to the Fortigate. So to configure the trunk port, configure, I'm in global configuration mode, interface, Ethernet 0/0. First of all, you describe the interface, trunk port for VLAN 10 and 20. So from there, switch port mode. Now we've got two types of modes here. Access, so that this one allow traffic, we've got this one, trunk. Then we've got this. In advanced switches, you'll see extended modes here, but in a layer 2 switch you'll just find access mode and the trunk port. So I want to set this trunk into the trunk port. I want to set this particular port into a trunk mode to ensure, you see, it is saying that command rejected an interface whose trunk encapsulation is auto. So it is in negotiation mode. So to ensure that, you say switch port trunk encapsulation dot 1Q. So you choose that. The moment you do that, you have forced it to operate under this particular. You can see it has changed to up. So from there you can do the whatever, switch port trunk allowed. So I'm going to allow some VLANs to pass through this trunk. So switch port allowed VLAN 10, 20. You see, description can say trunk port for VLAN 10 and 20. So I'm done configuring the trunk port. So it is time to save. You can say there are techniques of configuration in Cisco switch. So in this case, you can say copy, run, start. You see, it has saved. 19,000 bytes have been saved. So, or you can say write memory. Still, it will save. You see, or you can say copy running startup config. In this case, I'm copying the running configuration file into the startup configuration file, so that in any case my router or my switch restarts or reloads, the configuration are not lost. So that's, you should keep that in mind, or you just say WR. So thank you. I have configured the VLANs and assigned switch ports on this switch. So the next thing, I'm going to configure the DHCP on this Fortigate for every individual interface supporting these VLANs, and also configure the routing to ensure that this computer here can ping this, vice versa. So Fortigate, these are the things I'm going to configure on the Fortigate. I'm going to create sub interfaces on the Fortigate. So sub interfaces under port 2 to enable VLAN 10 and 20. Also under those sub interfaces, respectively, I'm going to configure DHCP server on those to support IP addressing or IP address assignment on these particular computers here. Another thing, I'm going to create a policy to ensure that traffic from this department goes successfully to this and vice versa. Because on this, I do not have the internet side, but still I can add. So I'll access my Fortigate firewall. Remember, by default, Fortigate firewall do not have a password. So the moment you access it, it will prompt you to change the password or to set your new password. You can see, and the host, this is the host name. The host name is set by default, so the username is admin, After there, you can see it is prompting for a password. Let me set my just simple password for simulation. You see it is successful. It has said that welcome. So from there, I'm going to go to configure, first of all, to identify the IP address that has been assigned from the server. You see my server is here, GNS3 virtual machine. This is the server that is hosting all these images that you are seeing here. So I have configured the server to ensure that it automatically assigns IP addresses on these particular devices here. So the server here, it is going to award, you see it is operating under this segment. So the Fortigate firewall is going to get an IP address from this, so that IP address is going to help me access it on this particular browser. So to check that IP address that has been assigned to the Fortigate, use diagonalize IP address list. So you see, this is the IP address that has been assigned from this particular GNS3 VM to ensure that I access it on the web. So from here, you can configure using the CLI, or you can do on the graphical part, on the graphical user interface. So I'll configure the host name on this CLI, and then the other things I'll finish them on the graphical user interface for you to get it clear here. So let's go. Config system global, then set host name. I can say NetLabs hub Fortigate 1. So you see it has not taken. I can host name, then NetLabs Fortigate. So you see it has not taken into consideration, because in Fortigate we use the word end to exit and save the configuration. The moment I type there end, then this name here, it will replace this one. So after there, end, you see it has changed. So that's how we do things in Fortigate. So let me now configure, access it in the browser. 192, the IP was 23. You see, accessed it. So what I'm going to do, I'm going to configure to create sub interfaces for VLAN 10 and VLAN 20, and also configure the routing to ensure that this computer gets an IP address automatic. Same applies to this, and it's able to ping both sides. So you see, this is the host name. So you will go, this is the dashboard. I had already created a video to show you how the Fortigate firewall is, the features and the functionalities I have talked about in my previous video. Check it on the NetLabs hub for more. So today I'm going to go to networks, then interfaces. This is the section that I'm going to work. Remember, just as using the router, I'm not going to assign any IP on this particular port, but I'm going to associate every sub interface to this particular main port. So first of all, you create interface. The name of the interface, I can say it VLAN 10. Sales, let me just say sales, then VLAN 10. You see 802.1q. So that is what we are using to do inter-VLAN routing. So then the interface, we choose the main interface here. Then VLAN ID, we give it 10. Then the IP address here of that, we give it 192. 168.11.1/24 according to that department here. You see, it is in that. So once you do that, I have assigned IP address here. You come here, you enable this one so that it will help us to test. Then you enable the DHCP server on that particular interface. It can finish with 200. Just then you save. So I have created that. For you to be able to see that particular sub interface that I have created, you see, it has been linked to the main port here. So I'm going to do the same for VLAN 20, finance, VLAN 20, port 2, 20. It is still a LAN. It is doing a LAN role. This is 12, 1, 24. You see, once you do that, you enable ping. Then this one, you enable the server here. You can give it maybe 90 or still 80, no problem, because it has 254 IP addresses. Then from there you can just say finance. Once you do that, then you save. So what I have done here, I have created sub interfaces so that these interfaces are going to help traffic from one VLAN to move to the other. But it will only do so if a clear route has been identified. So I'm going to create a route to move traffic from VLAN 10 to 20, then from 20 to 10. So that, but for now, let's verify if our computers are able to get IP address automatic and from the specific subnet DHCP. So the moment you see DORA, it's able to assign IP address. DORA is just a DHCP process. It means DHCP discover, then offer, request, then acknowledgement. The client machine discovers the server on the network. Then the server, upon having been identified, it offers the IP address upon the request made by the client. So save. You see, it has gotten what? 80, because 80, I had specified the IP address to start from that. So this is okay. You just say DHCP. Then you wait a bit. You see, it's successful. It's successful. You give it a save. Then DHCP. So it's okay, it's working. You see, this one, it has gotten from the same subnet here. So, but for now, this computer can ping this one. We can try. Ping 192.168.11.80. You can ping continuous. You see, it's pinging comfortably there. It's able to send the packets because there is a principle that communication, traffic from one VLAN, traffic in the same VLAN is able to move without any hitch. But traffic from one VLAN to the other cannot go through, not unless there is a layer 3 device. So you've seen. So we have achieved so far, but we've not achieved so, because this one cannot ping this one. We can try. This one has gotten which IP? 81, 12.81. So if we are here, then we try to ping 12.81. You see it's not pinging. ISMP sequence 1 timeout. So that is it. But the moment I'm going to create the route, this IP, this communication is going to happen. So just let me make it at least you see better. So let me be back, create now a route. So to create a route here, you will come to the policy and objects, then firewall policy. On firewall policy, there is an implicit route, but we will create a new route here, so that we will say sales to finance. This means that traffic from VLAN 10, which is sales, is moving to VLAN 20, which is finance. So the incoming interface is VLAN 10. The incoming interface is this particular sub interface that is bringing traffic into the Fortigate. So then outgoing, we are going to pick 20. Then the source, if you are not sure, just give it everything all. But in real network environment, such is prohibited. So you should be specific on which service you are allowing. So the moment you do that, you confirm everything, then so this rule here, this rule that I have created here, it's able that VLAN 10 can communicate to VLAN 20. Now let's check. Let's prove that VLAN 10 can communicate with the VLAN 20. So ping 192.168.12.81. You see it's pinging because I have created this particular, it is the function of this particular route that is enabling that communication to happen. So when I reload this, I expect these bytes to have increased here. So let me create the recursive route here, so that VLAN 20 can communicate to 10 now. So the same process. So finance to sales, then incoming port VLAN 20, outgoing VLAN 10, then this one always accept. Once you accept on this section, logs are allowed, you give it all. Then you see there is an error here. We allow all service, then we save. Once you save, the same can. So once you save, you see the rule is syncing, synchronization is happening. Once we do that, we can confirm this is PC2. Where is PC2? I want PC3. So this one is PC3 is having this one. The computer is falling under VLAN 20. So I want it to test if communication is happening effectively between VLAN 20 to VLAN 10. ping 192.168.11.80. You see it's pinging comfortably. So what we can check, let me show you how to capture these packets. So this computer here, it is pinging this computer. This 3 is pinging this computer. So we can get to this trunk port, this main link here, then start capturing the packets. We can see what's happening. So when piece 3 is sending to piece 1, piece 3 is the source, piece 1 is the destination. When the traffic is coming back, piece 1 is the source, then the piece 3 is the destination. So let's check. You see? You see, this is what is happening. It's changing. This one, after being the source, it turns to being destination in the reverse communication. So this is what happens. Thank you so much for following this particular lab from start to end. Feel free to subscribe to NetLabs Hub for more labs like this one. Thank you so much.